Hi, I'm Donna, Chief of Staff at the Centre for Advanced Research Computing, and I'd like to welcome you to University College London's booth here at Supercomputing 22. Why not meet the team?
We're very excited to be here at Supercomputing 22. High-performance computing is a real focus area for ARC. In particular, we're a major contributor to the UK Excalibur programme, which is the UK's exascale software initiative. UCL ARC is a new kind of institute in a university. It is both a research institute discovering new ways of using data, computers and software to carry out science and scholarship, and also a professional services centre delivering the skills, platforms, tools and systems that enable data and compute-intensive research.
I'm the head of research computing here at UCL, which means my team is responsible for the HPC and other infrastructure systems that we provide to researchers at UCL and across the UK through the Materials and Molecular Modelling Hub. So we have two primary HPC systems we provide to UCL. There's a machine called Kathleen, which is targeted at large MPI jobs, and a machine called Myriad, which is targeted more at high throughput systems, so things like biosciences and political science and things there where they analyze a lot of data. So as well as that, we also run a set of services through EPSRC's Tier 2 programs. Specifically, we host the machine for the Materials and Molecular Modelling Hub, which is a machine called Young, which is like a massive scaled-up version of Kathleen.
ARC is a mixture of combining the strength of traditional HPC high-performance computing services with a new research mission across e-sciences, computational sciences, and their applications. And ARC is following this, ARC is leading this, and says we have to combine this and develop our own strategy, a new way of doing research across these sciences, and to combine the strength of these areas in order to find new ways forwards for researchers doing research in the 21st century.
The story of ARC begins in 2012 with the founding of the UCL Research Software Group. Research software engineers work with researchers to ensure that the software that emerges from research projects is well engineered and sustainable. In UCL ARC, we're now trying to build on the success of that global movement to create 3 additional professions working with researchers in the same way. Data scientists, data stewards, who work with researchers to make sure data is well structured and discoverable, and research infrastructure developers who help build reliable, sustainable platforms to enable research workflows.
Apart from our research mission as ARC and representing University College London, we would also like to emphasize here at Supercomputing 22 the wide breadth of graduate training in computational and e-sciences at UCL, starting from MSc programs in scientific computing up to whole doctoral training centers in the foundations of artificial intelligence.
I teach medical students to use supercomputers. Medical and life sciences are a disadvantaged demographic in access to and use of high-performance computing, and this is something that we need to address. I lead a team that has been embedding this training in the undergraduate and medical curriculum at 3 different universities, and we have been watching our students' confidence and competence in their high-performance computing skills grow and develop. We've encouraged them to move to higher levels of use and to incorporate these computational methodologies as part of their normal working practice. The goal is to take people in this demographic or this field from Tier 5 to Tier 0 in the exascale as rapidly as possible so that they can contribute to the scientific and clinical endeavours that will make our quality of life and health and well-being better.
My research is on computational catalysis, so it focuses on simulating materials that accelerate chemical reactions all the way from the atomistic and molecular level to the mesoscopic scales. So we're using supercomputers to try to understand how these materials facilitate chemical reactions for processes like the catalytic converter in your car or chemical processes that produce plastics or other materials that we use every day. We've been working with ARC for almost 10 years, and we've been developing this software package called Zacros that implements the kinetic Monte Carlo approach in order to simulate catalytic materials.
We have recently implemented distributed memory parallelism on Zacros, which is a challenging problem because the simulation is serial in nature. And we did that by implementing the time warp algorithm in Zacros. This way, we have achieved some impressive speedups that made possible the simulation of really large systems that was not possible before.
So, for example, a simulation that would take about a year to complete with the previous version of the code, now we can do it in a month or less than a month.
So we think that our model, where we combine being both researchers and IT professionals, gives us a unique chance to be successful. And because we are building those platforms, we have a direct route to impact for the things we learn and discover. Rather than just going into a research paper, all of the ideas we generate about how to use data and computers to do research better can immediately influence the platforms and services we offer.
One of the challenges that all HPC centres are going to face over the coming years is the gap between what researchers expect in terms of modern cloud-based systems and what we provide, which is very traditional batch systems with a Unix interface. And I think we need to work out how to build a software stack that allows researchers to do their research without having to learn the old way of accessing computers.
Even more, we think that by combining the work we do in HPC with the work we do in supporting data infrastructures and the work we do in supporting large-scale experimental settings, we can bring these things together into an integrated digital research infrastructure, which we believe will be transformative for data and compute-intensive science and discovery.
So pull up a chair and let's continue the conversation about how UCL are involved in accelerating HPC to deliver cutting-edge, multidisciplinary research with global impact.